Getting custom manufactured parts can be a difficult task. Some local shops are great, but some require order minimums or just won't pick up the phone if you aren't a large company. That's where Xometry comes in. Xometry is trusted by engineers and designers at NASA, BMW, Bosch, and more. Simply upload the design file you want to be manufactured and boom! In a matter of seconds, you'll get an instant quote and access to dozens of manufacturing processes like CNC machining, sheet cutting and fabrication, 3D printing, injection molding, and more. Plus, you'll have plenty of delivery window options and prices available to suit your budget. Worry less and get the parts you need manufactured with Xometry so you can get back to building. Xometry, where big ideas are built.
Under the book, I thought it was very important. Right under the title, I put how a team, that's the big word, created one of the world's most ubiquitous technologies. So it's teamwork, and I'm really into that.
Hello and welcome to the Being an Engineer podcast. Today we're speaking with Paul McEnroe, who is the primary inventor of the Universal Product Code, or UPC for short, better known as the barcode. Paul is also the co-inventor of the handheld pistol grip scanner that reads barcodes at a distance, as well as several other technologies following these. Paul, welcome to the show.
Thank you very much. My pleasure.
Well, how did you decide to become an engineer?
Well, that's a very interesting question. I actually wanted to go into business or law, and so I ended up deciding on the business part of it. At least that's what I was talking about when I was like a sophomore, junior in high school. And I went and talked to a number of successful people in my area and so on and so forth. And they said, oh, if you just go study business, nobody's going to hire you to do anything significant. Go get a degree in electrical engineering. And after you do that, you get something they'll hire you for and you can get started. And then later go get yourself an MBA. So that's kind of the path I went down. But after studying engineering for 4 years, I got nice offers to continue with more studies, with all expenses paid. So I did that. But I did finally go back and I spent a few years at Stanford getting the equivalent of an MBA in business.
Terrific. Do you feel like the MBA helped you a lot as an engineer or in your career, whether it was doing engineering directly or as you got into
I don't think it really helped my engineering per se, but I ended up going into management. In fact, I was already in management by the time I went to Stanford and for business because I did engineering there first and then went over into the biz school. And so it did help me a lot with my career. And I think, I'll never know, but I think that the fact I was in business had something to do with why they chose me as a candidate to start them in a new business, because that's how I got into this barcode thing in the first place. IBM wanted to expand their technologies, increase into little different areas that were peripheral to base centerline mainframe computers. And so they were looking for somebody to do that. And they picked me. And I think it had something to do with the fact, I was living in Silicon Valley where a lot of that startup stuff was happening. And I had just was in the middle of or toward the end of my work in the biz school.
We're going to get into the barcode story deeply, for sure. Before we go there, I'd like to talk a little bit more about the MBA. I've talked with a lot of people who have MBAs, and I'm curious to hear from your perspective. You mentioned that you think it really did help you in your career. Perhaps that's why you were chosen to start this barcode venture. Were there other areas or other experiences you can point to and say that specifically I was able to do because I had an MBA?
Yeah, it's hard to say specifically. I was able to do it because of the MBA, and I couldn't have done it if I didn't. It has something to do with how you think and the way you go about things and so on. I would almost say it's a little bit off the track, but I'll come back to the MBA. I would almost say that in high school and in college, I went to college at the University of Dayton, which was near the home where I lived, and I did it because I could afford it because it was very inexpensive at the time, $12 a credit hour in those days. And, so 20 credit hours cost you $240 a semester. And I had work on campus because Wright-Patterson Air Force Base had electrical research you could do, and you could do it right there in between your classes. So that helped me a lot. But what helped me so much that I was referring to is in both high school and college, I joined the college debate team. And, the way that, a lot of people aren't familiar with it, but the way it works is the people that run debating across the country pick a topic of, national interest, and that's controversial, and nobody can decide which side is really right. And then that is the topic for the year. So you do a whole bunch of research on that topic, and then you travel around to different schools. For example, even though I was at Dayton, we traveled to Harvard and debated them and other schools up and down the East Coast. And you go into the room, there's a judge, and, you have tables, you stand up and debate the team from the other school. Only 5 minutes before the debate starts do you get to find out whether you're going to be in favor of it or against it. You have to draw straws. And so you learn to stand up on your feet. And, of course, the other people, you don't know what they're going to say. They may have done different research. And so you have to stand up on your feet and argue in front of an audience, and you've got judges doing it. And interestingly enough, in that whole time I did that, and I was captain of the University of Dayton debate team for 3 years, and I was on it for 4, and in high school for 2 or 3 more, I never, ever met, of course, this would apply to the college thing, another engineer in debating. They were all pre-law. There were English majors. There were, different kinds of business majors, international businesses, and that and the other thing. There were no engineers. And so I think that experience really did help me. If you're doing engineering, you have to stand up and explain it to somebody who's got the funding or the resources or the management team to keep it going. And you have to explain it to him, not with decimals and fractions and equations. You got to explain, what it's going to mean to the people who are going to use it, what's going to mean to him, how much money he's going to make from it, et cetera, et cetera. And I think that really helps. And when I went to the biz school at Stanford, by the way, that experience really helped me immensely in the biz school. Of course, it helped in the Rector school too. So I majored in getting my MBA. I majored in finance and marketing, and so, those are good fields to have a background in and a knowledge of, because that way you can talk to your treasurer of your company and pros and cons and all of that. So, yeah, that really does help out. And especially you're trying to get something funded, either because you work in a company or because you need to go to venture capital and talk to them. So I think that really helped me a lot. It opened doors. I don't know that I couldn't have done what I did if I had not done it. I won't go quite that far, but I think it made it easier.
Yeah, I think the debate, that's a huge pro tip right there. You don't hear that from many people, but I always say that communication is the route to success, right? You can only go so far with really good technical skill. You need to have really good communication skills, the soft skills. And what a great way to learn about communication.
Yeah. There's a little side story if you'd like that at Stanford. So one of the courses I took was business law. And they had a very famous professor who was retiring soon, and he was already a professor emeritus in the law and business school at Stanford, which was number 1 or 2 in the country at the time. And so his class was so popular that they had to hold it in a big auditorium where there were hundreds of students. And so that's where we were. That wasn't typical of Stanford at the time, but just because of this particular professor. So he would assign, cases for you to prepare on one day, and then the next day you came in and you were supposed to be prepared to discuss that case. So that he would say at the beginning of the class, okay, who would like to take the case for the plaintiff? And, 1 or 2 hands would go up out of 300, always mine. And then after he picked somebody, he would say, who would like to take the case for the defense? Well, my hand would go up again. And 1 or 2 others out of 300. Make a long story short, over the course of the semester, the quarter, whatever it was quarters, I think at that time. And I spoke, 10 times as often as anybody else. I mean, I didn't do it every day, but a lot. And so there was just one exam in the class, the final exam. And he came out and he told us all about the final exam. We're all going to come and take the final exam. And then he said, but I have one comment. And he said, Mr. McEnroe, who has debated me. And by the way these debates went, I would take one of those cases, either one, and then he would take the other case. And so you had to debate him. He was the other attorney. And so if you took the defense case, he'd present the plaintiff, you'd present the defense, then, he would, just make you look stupid by, his brilliance. Of course, he was familiar with the cases. He wrote most of them. And so then he said, would you like to change? And you'd say, yes, of course. And so then he would take the opposite case that you had just failed to win with, and he would be brilliant at that. And then you would repeat his case, but then, he had the arguments against that. So, you always lost. But I debated him in front of these 300 people, probably half or 2/3 of the meetings of the class sessions. So right before the end of the class, he says, I have one announcement, and that is, he said, Mr. McEnroe will not be required to take the final exam, and he will get an A for the course unless anybody has an objection. And nobody spoke, so I didn't have to take the final exam.
Oh, that's terrific.
And that was all because of debating. Even though I lost every debate, because I was debating him and he won every one.
Yeah. Well, I bet you gained a lot from that, right? Just the repetition, the practice over and over. Yeah. I was listening to something.
Of course, I ever took at Stanford.
Can't remember which band it was. It might have been the Beatles, but this book was, the author of the book was talking about how whatever band this was, and I think it was the Beatles, wasn't very good to begin with, but they would play so much, when most bands would be, once or twice a week, this band was every single night, right? From, 10 p.m. to 3 a.m. or whatever, every single night playing. And it was that practice and repetition that really made them the superstars that they became, right. Not this like inherent skill that they just were born with. It was practice and hard work.
Right. Exactly.
All right, Paul. Well, let's get into the barcode, which is a big deal, right? Everyone knows what a barcode is. I mean, aside from some, maybe tribes in the Amazon forest, pretty much everyone in the world knows what a barcode is. That's huge. How does that make you feel, knowing that you have engineered something that the entire world uses?
Yeah, it is mind-boggling. I don't think about it all that often. I do enjoy going to the grocery store, and I'm the shopper in the family, and I go there probably twice a week, sometimes 3 times. And, I'm on a first name basis with all the people in the in the Albertson store that I go to. It's a standard size store, the only supermarket in my local town. And, I'm friends with the store manager and all the checkout clerks, and I give them a bad time when they pick up the scanner that I patented and, the handheld one and scan things. And they give me a real bad time if something doesn't work right for them. And
that's great.
But I don't think about it too much other than that. To be honest with you, you just go on, and I'm just very fortunate that something that I worked on happened to I was there at the right time, at the right place, with the right technology, and it all went together and it went big.
So what was the problem that drove development of the barcode? What was life like before the barcode in that context?
Yeah, well, back in the supermarket or in the retail stores, everybody was just hand changing prices on the merchandise, can of Campbell's soup. In the old days, if you went to a store and you went to the soup aisle and you wanted to buy a can of soup, I was taught, well, okay, if you look at to the back of the shelf, you'll probably find a cheaper can of soup because they hadn't bothered to pull all those cans out and reprice them. And that was a little trick that people did. That was one way it was different. They ran out of stuff a lot because the only way they could tell whether they had it or not was walk back and forth up and down the aisles and then go hand order it, and so on and so forth. And the checkout lines were long, and by the way, when you got checked out, you couldn't tell what you paid for different things. I mean, unless you happened to be washing at the moment when they keyed in the price, because the checkout clerk had to pick up the item, twist it around to see where the price was, and then key the price in the cash register. And by key the price, like if it was 13 cents, they keyed 1.3, and then another thing, and then they went on to the next one, and so on. So that's the way it was. And that problem had been articulated very well by the Supermarket Institute and by the commercial so-called rags magazines of the day that were describing, gee, we'd like all these things to be different. Now, so that was happening in supermarket and retail. It was a little different, in your stores like, take Macy's and Sears and so on and so forth. They had lots of problems of reordering and inventory control and price management, all that kind of stuff. They didn't have so much of a problem in terms of speed of checkout, which was predominant in the supermarket area. So that was happening, and that had been written down. People had tried to do these things. One of the primary competitors to the code that we developed was a bullseye code that had been developed by a guy who later joined my team, Joe Woodland, back in 1948. But they couldn't scan it effectively or reliably. There were problems with the code. We couldn't scan it reliably ourselves, even with new technology, because the code didn't work well in terms of eliminating errors. But in addition to that, another problem was there was no good light source that would allow scanning of it in the 1940s, 50s, and early 60s. But then I had started at IBM in 1960, and I had been working in a think tank in Los Gatos, California, which is in the Bay Area, Silicon Valley. And I've been working there for about 9 years, doing different types of research, input-output things mostly. Scanning was my specialty. And so I was doing that. And one day into my office walked a gentleman named Jack Keeler, later to become president of IBM. But he was just a more junior executive at the time. And he said, hey, Paul, we have a proposition to put in front of you. And he said that they would like me to pull together an effort to study different possible fields of endeavor to decide maybe what we should go forward with to expand IBM's product line so that we could continue our growth. So then he went on to tell me that the president and CEO of IBM at the time, a gentleman named Frank Carey, who's very famous, one of the most famous ones, had decided that IBM's growth, which was so phenomenal that, by the way, if it had continued, it would have passed the gross national product. I mean, if it continued at the same rate, which of course is a contradiction and an impossibility, so that couldn't have happened. But if you just put the numbers in, that's what would have happened without using any logic. Anyway, so he said, we need to expand the things that bring data to the mainframes and to the back room and to the computers and so on and so forth. And so why don't you guys, he's talking to his staff, go out to Silicon Valley, buy some nice companies that are working in these peripheral areas, and let's get started with startups in IBM. And they said, no, Frank, you just don't understand. Every top-notch engineer who can do whatever they want and work wherever they want, on the morning after you say you're going to buy the company, they will quit. And they don't want the IBM white shirts and blue suits and wingtips. And, also, of course, IBM didn't have the same kind of compensation plan. I mean, the stock plans weren't, you weren't going to get rich quick. You make a good living and have a very secure future, but, it's not a startup. And so Frank said, okay, this is what Jack told me, Jack Keeler, the guy that came in my office. He said, okay, then do the next best thing and find somebody in IBM to do a sort of a pseudo startup, So what we would do is, get some people in IBM and try to treat them like as if they were a startup, because he knew you couldn't follow all of the red tape and rules of getting an IBM product out the door and be successful in a startup kind of a mode. So this would have to be treated differently. And so that's what they asked me to do. And so, like I said, I think the reasons that they did were in part, I was in Silicon Valley, so I was used to that. I'd been around for about 9 years. I had expertise at input, output in computers. I don't think they paid attention to the fact it was scanning or not. And so I think that's had something to do with why they knocked on my door. And so then I got two helpers in IBM, one older, more experienced guy in manufacturing and engineering, and a second guy, a brilliant young mind who had an MBA from Harvard and a bachelor's in engineering from MIT. But he never really worked in engineering. He understood it all, but he hadn't done anything. So anyway, we started that up, and we got to look at the different fields of that were out there, thinking of how can we grow the computer field. And the first thing we looked at was banking, and we decided, okay, we liked the way that was opening up and the way applications that we could have developed. But there was already a group I found out that had started that in IBM, and I didn't want to conflict with them and have another internal war. So they pushed that aside. And then we looked at point of sale. And there I thought, bingo. I had grown up in Dayton, Ohio, in the shadow of NCR, and that's their headquarters, and most of their factory was in Dayton, Ohio. They were the biggest employer there outside of General Motors, who was humongous. And so I was familiar with their product, and everybody is a big old cash register, right? Cast iron, a whole keyboard, big long throws, 2-3 inches on the throw of the key, and then white letters, black on white, come popping up through a glass window and tell you what the price is for that item, and so on and so forth. And of course, there were little keyboards that had been used in the check stands as well, but in conjunction with the cash register, with big cash drawers and all that stuff. And NCR had a monopoly almost on the whole, around the whole world. Almost every store in the world had an NCR cash register. So the market was already laid out. There it was. Supermarket stores, retail stores, they all had National Cash Register devices in it, probably 95%. So I thought that's what we can go after. And then I was studying their materials. By their materials, I mean the industry materials, where they were calling for faster checkout, automatic scanning, inventory control, et cetera, et cetera. And I'm thinking, hey, we can do all that stuff. I was a scanning person. We can do that. We can, I knew that the light problem had been a problem for scanning before, but I also knew and had worked with them in the laboratories that the helium neon laser had just been developed. And that was a low cost, I thought, safe device that we could use in the scanner. And then there were a whole host of other things that we could do. And it fit IBM because it required a systems solution. You got the barcode, or we didn't have barcode yet, but you have some kind of a symbol, and you're going to read the symbol. So you got to have computer equipment. You got to transmit the signal from wherever you're going to scan it to the back room, and then to the warehouse, and then to headquarters, and so on. You got a lot of communications, and you've got to put a lot of stuff on the file. And we started studying stores, and there were Costco-like stores in Europe, all over Europe at the time. They were called cash and carry. They had 40 check stands, some of them, in the front of the store, and great big warehouse type situations in the back. People would go in there and shop once a month or once every 2 weeks or something. But still, you got 40 people at the front of the store, and they're going to scan something. Then instantly, 40 different signals could go back to the computer in the back room, and it had to answer all of them before any of them could tell there was any delay. Well, that was beyond the speed of capability of inexpensive communication systems and of the file systems. So you knew that. And if you take the price off the merchandise, then you got to have a no-fail computer, because there's no other way to get the price to put it in, because there's no prices on anything except on the shelf. And you can't run back to the shelf and look at the price of something every time the person has a different item. So anyway, I could see the systems requirements for this, and I could see that we could do all of that stuff. So we went ahead and proposed that we develop a new system, come up with some kind of a symbol. We didn't know what kind of a symbol that we could scan and propose it. So we did that and put a proposal in front of IBM executives. They bought it. I asked for a modest amount of money. It was $300,000 the first year, $1 million the second year, $3 million the third year. And after that, we'd have to have a lot more, or we'd be fired. It'd be a failure. So that's what we did. And we proposed that we start that kind of thing, and we were accepted and went ahead with the proposal. And that was 1969.
Terrific. So tell us a little bit about how barcodes work. I mean, we have all these little vertical lines next to each other, different spacing. How does it work?
Yeah. So you scan, that is to say, like if you were to read it with your eye scans, let's say from left to right across, and you can see, and some bars are fatter than others, and then they have a white space between them and the next bar. The white spaces are different in width too. And so if you do a little calculation, mathematical analysis, and using binary technology, of course, you can just, with 2 bars and 2 spaces, you can get all the digits, plus have some spare ability to do error checking and so on and so forth. And so we just break it down. So if you look at the barcode on anything now, a typical barcode, the kind we proposed, and we offered different options of it. You could cut it in half. You could make it smaller, blah, blah, blah. But the standard barcode had 5 numbers originally on the left-hand side and 5 numbers on the right-hand side, and 3 longer black bars in the middle, and some bars to start extra that didn't have a number below them. Well, above each of those numbers, you take 2 bars and 2 spaces, and that's going to be the code for that number. So so the number 1 might, I can't remember what it is, but it might be, a wide black followed by a narrow white, followed by another wide black, followed by another wide white. something like that, whatever they were. And so you have to create, since you don't have the eye of a human being, a small spot when the spot has to be smaller than the bar so that the spot is completely absorbed by the black when it's in the black, but reflects back off the white when it moves onto the white. Now, I need something very important here that I think caused us to be a success and other people not to win, was that the typical way everybody did that, or almost everybody, was they measure the width of a black bar by that little spot coming across. Everybody had a little spot. And then they compare it to the white space next to it. But for the first 5 to 8 years, the bars had to be printed cheaply in store on a very inexpensive machine printer and then stuck on the package. And those machines typically had too much ink or not enough ink. It wasn't the quality that you get if Kraft is putting it on their package or Post is putting it on Wheaties or whatever, which is very high quality. So if you imagine that the printer's got too much ink in it and it's printing this black bar, and you're going to measure and compare the width of the black bar to the width of the white space next to it, if the printer has too much ink in it, all the black bars are going to get too fat, too wide, and all the narrow spaces are going to get too small. And so when you divide the width of the black bar, you get a big number on the top, and you're dividing it by the white space, which is a small number, and that's getting smaller because there's too much ink. And the error compounds tremendously, and you just get garbage. And vice versa. If the printer didn't have enough ink, all the white spaces get too wide and the black spaces get too thin. One way that we built that, and this is just one of about 10 different really magnanimous things there are about the details of the code, is we said, hey, we're not going to do it that way. That we're going to measure the leading edge of the first black bar to the leading edge of the next bar, whether it's next black bar. And we're going to take the trailing edge of that first black bar and measure the distance to the trailing edge of the next black bar. Now, it's the same information, the same kind of information, same amount of information, but it's done in a different way. And the errors cancel, because if all the bars are fatter, all the left sides move left. And if there's not enough ink, they all move right. And so the errors cancel. And so that's one of the little tricks about our code that was different from everybody else's code. And so that's the way reading the bars work. And by the way, another... Go ahead.
Are there like an unlimited number of I guess, numbers that a barcode can represent? I guess you just add more bars and spaces to create a bigger number as you run out of them.
That's right. But the standard now, I think that the most that I've seen are 6. You can get 6 numbers there. They have another number hidden in the leading bars, the 3 bars on the far left or the 3 bars on the far right. And that has a country code in it. So, you get the country code. So if it's China, okay, it's that one. And then if it's the United States, it's another one. So yes. And that's what the barcode is really good at, just 10 digits. Now, in the early days, the retail people, the Macy's of the world, they wanted not 10 characters, numbers. The supermarket just wanted 10 digits and just the 10 digits. They didn't want letters. The retail people wanted numbers and letters, and they wanted 36 of them, because they wanted to put on their little tag on the merchandise, who was the designer? What was the designer's name? What color was it? And they didn't want you to just the standard colors. They wanted colors that, the ladies are most likely want, like chartreuse or something, not green. And so for them, we used the same code in terms of how it was written and everything, but we recorded it magnetically so that you could put the numbers or the characters closer together, because you could get a lot smaller, if you like, dimensions between the markings for characters in magnetics than you could at the time, than you could in optics. And so that's kind of the way it went. So we proposed a code to the National Retail Merchants Association and to the Supermarket Institute. It was the same code, but one was encoded magnetically on a magnetic stripe, like on the back of your credit card, and that was stuck on a sheet of paper and attached to the merchandise for retail. And then for supermarket and the fast food stores, later came to be Kmart's and so on, it was just the barcode, which just had the 10 digits or 12 if you like.
What happens when you run out of numbers? Do they get reused?
I don't think you run out of numbers. If you think about it, with 5 numbers, you could get 99,000 different, 999 different numbers. And that's more than there are items in a supermarket. And then so that's just one side of the label or one side of the barcode. The other side, it has another 5 or 6, and that does the manufacturers. And as I said, buried in the bars on either the far left or the far right is the country code. So you got a country code, and then you've got these number sets. And so call it 100,000. It's one less than 100,000. So there's less than 100,000 companies that are building grocery items in every country, and there's less than 100,000 items in the supermarkets as well. So it hasn't been a problem. Now, for applications where you want a lot of information, new information, not 50 years ago, but now, then the QR code is an expansion of the barcode that we did, and it's a 2-dimensional code. So, you can also scan the thing in addition to left to right. You could scan it top to bottom or bottom to top, as well as left to right. And you see the little dots in there, and you can make the dots smaller and so on and so forth. So you can get almost arbitrarily as much information as you want. So nowadays, it's something you want that's inexpensive, very fast to read. Everybody's used to it. Everybody puts it on. It's very standard. It's inexpensive, easy, cheap, and real fast scanning. And you don't have to orient it. The barcode wins that battle, and it's won it for 50 years, and it's going to keep winning it for another 20 or so. But if you want to put something special on that you're going to get a lot more details to, like you want to put a sticker. I'm looking at my computer here, and it's got a QR code on a sticker on that I've never taken off of it, on the base right below the keys. And so you probably scan that, and it'll tell you where you can buy the manual and all that kind of stuff. So that's what a QR code is for. But the barcode, does its job where you can get by with the number of digits you got. And of course, if you just have one more digit, then you multiply by 10. So where I was talking about 100,000, then it becomes 1 million.
So let's go back to the numbers, because I have another question there. So does that suggest that barcode numbers live within their own unique ecosystems? For example, a grocery store ABC is going to have their own barcode number system, whereas grocery store XYZ is going to have a completely separate system, even if they are selling the same products?
No, Aaron, it doesn't go by the grocery stores. It does go by the manufacturer of the foods. So let's take Campbell's chicken noodle soup, right? So Campbell's soup is going to have a code, right? They just have one code, let's say. I mean, they might have different factories and so on, but let's just simplify it and say they have one code. So that's the number to the left is Campbell's soup. Okay. Now the numbers to the right. So they got 99,000 opportunities. So they pick one. They pick a number. Let's say they pick the number 127, 00127. And they assign that to chicken noodle soup with low sodium, medium size. And that number goes on. Then that will be the same for all Campbell soups going to whatever supermarket they go to.
Okay. So forgive me. I'm a little slow sometimes. I'm starting to get there, but I'm not quite there yet. So if there are only 100,000 unique numbers, I mean, surely there are more than 100,000 products in the world that are using barcodes. How does that work?
Well, but they got to be 100,000 from Campbell Soup, right? Because Campbell Soup's is they have their choice of however many numbers they want over there. And then, so we have an institute. It used to be called the, I've forgotten the name of it now, but the GS1 that assigns the codes. And so, people haven't really been complaining about running out of codes. So, they assign Campbell's Soup, and then Campbell's can say, okay, let's say we make 50 different kinds of soup. Okay, so they get 50 numbers for their soup, and then they might get 50 more numbers for something else. And so, but those are just only get used up by Campbell's. And now, you can go to another manufacturer.
So the manufacturer has some unique code that defines the manufacturer.
Yeah, it's the left side. Let's just take. I'm not sure whether it's left or the right, but if you look at a code, you see two sets of numbers, right? 5 on the left and 5 on the right. So one side of it is for the manufacturer.
Okay, so that infers that there are not more than 100,000 manufacturers using barcodes. Okay,
in that country, right?
In that country. Okay.
Yeah, and then we expanded it to 6. So now it's that there are less than 1 million.
Got it.
When we started, it was 100,000.
Okay, interesting. I've wondered how that's worked for a long time, so this is really interesting to hear it.
Yeah. So what the different stores, they can do different things with it. So they can program our equipment. So the Campbell Soup doesn't want to have to worry about where the can of soup is going to go, whether it's going to go to Kroger's or whether it's going to go to Albertsons, right? They just want to make the soup.
Right.
They don't have to worry about where it goes. So they ship the soup. It's got the same barcode on it everywhere in the United States. Okay.
I see.
So, I mean, in a different country, then they have to deal with the country code. But in the United States, they would have just one number for one unique can of soup.
I have, or my company, we have purchased UPCs for products that we have developed, right? We'll design the product, and then we'll design the packaging for it as well. And we'll put a barcode on there. We'll go off to, I can't remember the website that we've used in the past, but there's somewhere you can go and buy a UPC, and then you have that PDF file or AI file, whatever.
See, when we built it, we started with it. It was called the Uniform Product Code Council in Washington.
So that's the organization that manages GS1 and GS2. And what are the economics of that? We're all using these barcodes. There are all these companies out there, less than 1 million, that have their own unique codes. Someone has to manage that.
The Supermarket Institute recognized that, and they set all that up, and they did a magnificent job. So they set it up, and that organization has continued to this day. And it's like you said, if you have a company, you call in, you get assigned a number, and then you have as many different products as you have, and you get assigned the numbers for those products, and that will work. And then if you say you want to sell it in some other country, well, then they'll give you another number.
Fascinating. So are the manufacturers paying to have this unique code that's specific to them? Is that how that works?
Yeah. But it's a very minor amount, in the scheme of things.
Sure. Yeah.
It's mostly cost-based. I mean, I'm not certain whether it's a nonprofit or whether it is, but the companies that pass it out, I never paid attention to that. But it's a minor expense. In all the years I've been involved with it, that I've never heard a complaint of anybody about it's too hard to get a number or too expensive to get a number. At least I haven't heard that.
Yeah, I was just curious about how that all worked in the background. I interviewed someone on the podcast a while back who worked at Battelle, and if I remember correctly, he had indicated that they worked on barcode or barcode scanner. Maybe it was tangentially. Was there some kind of partnership with Battelle, or am I just completely misremembering this?
No, they were involved. So the way it worked is the Supermarket Institute. Now we're skipping away from the national retail thing, which used the magnetics, just the supermarket side. So the Supermarket Institute they set up these the people to hand the code out. But before that, they formed an ad hoc committee. They formed it in 1970, I believe, and that was to select the code. They made several decisions, which were phenomenal. One of them was that they would not entertain any code to be selected unless it was put in the public domain. They didn't want to set up anybody to get rich on this. You got to put it in the public domain. You got to be willing that any money you make on it is going to be to provide manufactured products that supermarkets would buy to put in the store, like the scanners and so on and so forth. So that was one thing. The second thing was they realized, and this was brilliant of them, that they did not have the skill set to decide which is the best code. They couldn't even understand how does it work. They don't have that kind of engineering. And so they went to the number one consulting company for this kind of thing in the world at that time, I believe, McKinsey and Company in back east. And they hired McKinsey, and McKinsey put two top-notch people in charge of the selection. And so they worked with the ad hoc committee. And the ad hoc committee said, let's go invite manufacturers who would be interested in getting into the field of providing products for the supermarkets that we can buy to put in there to do the scanning and to do the inventory control and everything. Let's invite them to propose symbols that would be scanned. And so they did. And they said, well, we're not going to be able to pick the best symbol, so we're going to get McKinsey to do it. So McKinsey did it. And so McKinsey suggested to the Supermarket Institute that together they hire different people to do testing. One of those was Battelle. And so that is how Battelle was involved from my memory. And so we did work with Battelle. We sent them product, they tested it, and so on and so forth.
So fascinating hearing about the history.
Yeah, I didn't see the results of their tests of other products because that was proprietary. But I did see their results of ours, and it was good. And when our product was selected, very interesting. I was told that and this is all covered in the book. One of the guys from McKinsey came out of the room where the ad hoc committee was meeting to do the selection and said, I'm sorry, Paul. He said, it's clear you guys have the best code and the most reliable code and the most error-free code, but I don't think they're going to be able to select it because they're worried that if they select Big Blue, that was the nickname for IBM at the time, if they select IBM's code, there's going to be too much social back pressure that they just went with the biggest, most expensive company in the world. We were the largest company in the world from point of view of profitability and value of our stock and so on and so forth. And so he said, I don't think they're going to be able to select your code, even though it's far and away the best. And I said, look, and I had no authority to do it. I'm telling you right now, I did. But I didn't have the authority at the time. I said, I could see that I was going to lose all the work we had done because now I told you I started on this in 1969. They formed the ad hoc committee in 1970, but now it's 73. And it's like the end of March, 1st of April of 73. So 4 years of work has already gone into this. We've got the code. We've published all the stuff on it, et cetera, as other companies had too. But I can see all that going down the drain because they don't want to go with Big Blue because of, the feelings everybody would have. They just went with the biggest company. So I said, just before I came to the meeting, my team showed me a couple of minor improvements that they've made to the code. Let me tell you what those improvements are. You can make those improvements to the code. That'll make it different. And you can say, that's your code. You don't have to say you selected the IBM code. And he said, well, it's a long shot. I'll try it. He walked back into the room. He came back out sometime later and said they bought it. And in the book, I printed a copy of the page in the Business Week magazine, April 7th, 1973, that shows pictures of the finalists of the code, of which there were 7, and the code they selected, which, quote, is different than all 7, different than ours. But you can't tell the difference. Our readers still read it. We didn't even have to modify them at all, because they were just, only thing we did is we had previously had the little bars on the left and the right go up above the ones in the middle, and we just cut them off at the top. That was one of the changes. I even forget what the other one was. It was very, very minor. But that way they didn't say they selected IBM's code. And by the way, the Business Week article made fun of it. And it said in there, it said, you look at the pictures of the codes. I don't remember the exact words it was, but look at the pictures of the codes, and you'll see it looks exactly the same as the IBM code that was submitted, but they said it's their own. And
oh, wow. Maybe that came from your MBA training, huh? Quick, astute change. All right. Well, Paul, this has been a great conversation. Thank you so much for joining me on the podcast today. I've got one more question for you before I let you go. Specifically within the context of your role as an engineer, what is one thing that frustrates you, and conversely, one thing that brings you joy?
Oh, boy. I mean, it just in general, the things that frustrate us engineers, I think, is when we see people making decisions in all kinds of social affairs that are just not supported by science. They're just not the physics of the world that everybody knows, and that gets to be very frustrating to us. The thing that makes me happiest is, looking around at the things that engineers and of all different types have been able to do for society. And I think that I know when I went to engineering school, I had a lot of professors that were very special, and they all kind of said, you measure what you do and how successful you've been, not by how much money you've made and this and that, the other thing, but more by what improvements have you made to the way people live their lives and make them happier. And I think that's what, engineers can benefit the most from. And so some people do little things, some people do big things, whatever. We did kind of a little thing, but it had an effect on a lot of people. And that's what gives me the most joy, is thinking of the numbers of people. We're thinking we get 10 billion scans a day across the country, and it's ubiquitous, and the meaning of ubiquitous is in sometimes thought of as it's so prevalent you don't notice it. We don't notice barcodes. We don't think about them all the time because they are everywhere, and we see them all the time, and that's the good part of it.
Amazing. Well, Paul, tell us the title of your book and where people can find it. And if people want to get a hold of you, how can they do that?
Sure. It's called The Barcode. And under the book, I thought it was very important. Right under the title, I put how a team, that's the big word, created one of the world's most ubiquitous technologies. So it's teamwork, and I'm really into that. It's available on Amazon and Barnes and Noble, and it's going to be a hardcover version is on its way out. It'll be there very soon, and it's available in paperback and in Kindle now. You can get it very quickly.
And how about if people want to connect with you? How can they do that?
Well, they can, I think what I'm going to do is I'm going to get a website started, because there's so many people that want to get involved with me that haven't been before. But right now, I think the best way is contact my publicist, which is Smith Publicity. Those are the people that you've been working with. And they can put them in touch with me. But I think I'm going to get I'm going to get a contact set up by some website. I don't have one yet, but I think that's probably what I'll do. And but Great. They always can go to Silicon Valley Press, SVP, Silicon Valley Press. It's in Silicon Valley. You can Google them, and you can get in contact with me through them. That's my publisher.
Perfect. That brings up a good point. Often the guests that we have on the podcast, including Paul, are not people that we find, but people who find us. And oftentimes publicists like those that Paul mentioned will reach out to us here at the Being an Engineer podcast and say, hey, we've got this wonderful guest that we think would provide some valuable content. And we love that. Not everyone's a good fit, and we don't charge anything for guests to come on the show, but if it is a good fit, then we love that. So if you're listening to this and you think to yourself, I know someone who would be a great guest on the podcast, someone who's engineering or engineering adjacent, maybe has a great story to tell, absolutely reach out to us and suggest this guest, make an introduction. And if it's a good fit, we'd love to have those individuals on the show. So I think that's it for this episode. Paul, thank you so much for joining us today and sharing your story with the barcode and sharing the barcode with literally the whole world.
Yeah, you bet. Well, thank you. I've enjoyed it very much.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.